Hello everybody, it's me, Code Talker Looter with more Python. And here we are with the part 4 of the Starting Out with Python course of the Tony Gaddis book. And we are writing to, we already finished the exercise number 18 on chapter 2, but chapter 2 still keep going. Chapter 2 is just so rich in content. So that's the checkpoint that we left off, and we're gonna go about here. Let's read out this part of the book before going into more detail on the next exercises, shall we? So, more about data type. So far we have discussed only basic ways to display data. Eventually you will want to exercise more control over the way data appear on the screen. In this section you will learn more details about the Python print function. You will see techniques for formatting output in specific ways. Pressing the print function, ending new line. So print 1, 2, 3. Each of the statements shown here displays a string and then prints a new line character. If you don't want to, if you do not want the print function to start a new line of output when it finishes displaying its output, you can pass the special argument end equal to the function as shown in the following code. So print 1 and Okay, notice in the first two statements the argument end is passed to the print function. This specifies that the print function should print space instead of a new line character. Okay, that's cool. Specify an item separator. Okay. When multiple arguments are passed to the print function, they are automatically separated by a space when they are displayed on the screen. Here's an example demonstrated in interactive mode. Print 1, 2, 3, 1, 2, 3. Okay. Separate. Oh wow. 1, 2, 3. Oh, okay. So that cuts the space. Cool. Oh, nice. All right. Escape character. Escape character is a special character that is preceded with a backlash, appearing inside a string literal. Okay, so that we actually learned it last time. Oh, we actually learned it in JavaScript a little bit. String literal. Okay. All right, this is pretty simple. Pretty simple. Okay. Program 219.py. So this is the number. Wait a minute. Alright guys, I was just confused. I just wanted to make a comment, but of course the Python's comments start with a pound key. So yeah, I'm sorry, I'm fucking dumb. There we go. It's called no formatting.py. This program demonstrates how a floating. I'm sorry. Ooh, sneezes. I think I'm getting sick. Floating point number is displayed with no formatting. Amount due equals monthly payment. Amount due. And then print. The monthly payment is monthly payment. And we just run a Python file. And it is 416. Blah, 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 blah. Okay. because this program displays a dollar amount, it would be nice to see that amount rounded to 2 decimal places. Fortunately, Python gives us a way to do just that, and more with the built-in format function. 2F. So 2F, I believe, is a formatting for just 2 zeros or just 2 decimals. The first argument, which is the floating point number, is a number that we want to format. The second argument, which is the string 2F, is a format specifier. Here's the meaning of its contents. Okay, that makes sense. Formatting. Okay, now let's go for Python program to py. It's called formatting.py. It says this program demonstrates how a floating point number can be formatted. Amount due is monthly payment is amount due divided by 12. Okay, print the monthly payment is format. Oh, it's a function, recognized function. Monthly payment, and then we do 2F. We just save and then run, and you'll see here. Oh, wait a minute, what's happening? Oh, I missed the period over there. Oh, there you go. Awesome. And now we can argue that also, instead of showing the same result all over again, we can input the amount due. We're just stating the amount due, right? For example, just asking for the print input amount input something, right? I'll have to tinker, but it's super simple. Anyway, for the sake of time, let's go straight to this next exercise. So program 221.py. It's gonna be $display. Oh, cool. Okay. $display.py. This program demonstrates how a floating point number can be displayed as currency. Monthly pay equals fingers, please work. Annual play equals monthly pay, times 12. Sprint your annual pay is format annual pay, comma, 2F. And then we make a separate. There you go. We save. All right. Clear. There is a format annual. There is a Line 9, format, annual. Oh. Well, first of all, let me rename it. Annual pay. Still annual pay. What's wrong? Invalid syntax. Perhaps you forgot a comma. I thought I put a comma in there. There's a comma here. Format annual pay. Oh, here. Forget the comma right here. Comma. Thank you. There you go. I'm sorry. Sorry about that. Let's clear again. Clear again. And pay. Your annual pay is 60,000. There you go. Okay. Which has a slip of mind. All right. Let's get going with specifying a minimum field width. The format specifier can also include a minimum field width, which is the minimum number of spaces that should be used to display the value. The following example prints a number in a field that is 12 spaces wide. Okay. In this example, the 12 that appears in the format specifier indicates that numbers should be displayed in a field that is a minimum of 12 spaces wide. In this case, the number that is displayed is shorter than the field that is displayed in. The number 12, 345 out of the 68 uses only 9 spaces on the screen, but it's displayed in a field that is 12 spaces wide. When this is the case, the number is right justified in the field. If a value is too large to fit in the specified field width, the field is automatically enlarged to accommodate it. Note in the previous example, the field width designator is written before to the left of the comma separator. Here is an example that specifies field width and precision, but does not use comma separators. Print the number is format, blah, blah, blah. Enter the form number is, okay. Field width can help when you need to print numbers aligned in columns. Okay, and we're going to learn columns. Is kind of lengthy, but not that lengthy. Program 232.py, and we're going here. Damn it, JavaScript, you fucked me over. Columns.py, and it's this program displays the following: loading point numbers in a column with their decimal points aligned. So num1 is equal to 127.899. Num2 is 3465.148. Num3 is equals 3.776. Num4 is equals 264.821. Num5 it's equals 88.081. Excuse me. Num6 is 799.999. Then display each number in a field of 7 spaces with 2 decimal places. print format 1, okay, comma 7.2f, and then we do the same thing for all of them. Basically it's the same thing for, okay, so we're gonna do here 1, 2, 3, 4, 5, and change it to 3, 4, 5, 6. We save, and then we click clear. And there you go, guys. That's it. 127.93.465.15.378. We just formatted them, all of them. Pretty cool, right? Pretty cool. Okay, we clear. And let's go with, how long are we? 17 minutes. Not bad, not bad. And we just reached the checkpoint here. How do you suppress the print function ending line? I'm gonna put this on. You can then just pause it. I'm gonna give 5 seconds. You can pause it, and then you can just put it in your and then note blocks or block note, whatever you have in there, in order to make the checkpoint. Do the checkpoint at your leisure. But we're going to continue. We've been just here for 18 minutes, so I think we have time for more exercises. Talking about exercises, look at this. 2.9, section 2.9, named constants. So the concept, a named constant is a name that represents a value that cannot be changed during the program's execution. Imagine for a moment that you are a programmer working for a bank. You are updating an existing program that calculates data pertaining to loans. And you see the following line of code. Amount equals balance times 0.69. Because someone else wrote the program, you aren't sure what the number 0.69 is. It appears to be an interest rate, but it could be a number that is used to calculate some sort of fee. Simply can't determine the purpose of the number 069 by reading this line of code. This is an example of a magic number. A magic number is an unexplained value that appears in a program's code. Magic numbers can be problematic for a number of reasons. First, as illustrated in our example, it can be difficult for someone reading the code to determine the purpose of the number. Second, if the magic number is used in multiple places in the program, it can take painstaking effort to change the number in each location, should the need arise. Third, you take the risk of making a typographical mistake each time you type the magic number in the program's code. For example, suppose you intend to type 069, but you accidentally type .0069. These mistakes will cause mathematical errors that can be difficult to find. These problems can be addressed by using named constants to represent magic numbers. A named constant is a name that represents a value that does not change during the program's execution. The following is an example of how we will declare named constants in our code. Okay, interest rate, This creates name constant, name interest rate. All right. So basically, you make a variable for that. Okay. And we reach another checkpoint. What are the 3 advantages of using a named constant? Write a Python statement that defines a named constant for 10% discount. Super easy. Well, apparently we actually reached to the chapter 3, which is decision structures and Boolean logic, which we're gonna do it in the next episode. Actually, I had to tell the truth. There was a last exercise in chapter 2, which was about the turtle graphics, but it was a very lengthy one, and I don't think I can put it in this video, but I'm gonna do it. I'm gonna do it in a live stream, which I do basically coding ASMR. So I'm gonna do that one in that um in that live stream. It's about how to actually do turtle graphics, stuff like that. It's very lengthy. It's like 102 lines of code, and I am not. I'm too lazy to make that. I put it in a video. Imagine how much time will take me in order for that. So that's gonna be for the live stream. Probably it's gonna be done. I don't know when, but with that being said, we reached chapter 3, and in chapter 3, we're actually gonna cover a lot of things. Boolean logic, if it is either true or false. That's an interesting concept that is in programming that is super good to know. So, guys, click like, subscribe, and see you guys next time. Bye bye.